so I'll just build this from scratch. So this will be using Firefly to interface with this data that's coming out of the board. So if you're going to do like a data flow diagram of what's happening here, the board is outputting a list of values from this other computer. It's streaming it to this computer, which is reading it and displaying it like this. So if I unplug this and then plug it in again, it'll just reset and then start sending the values again. But I'd have to obviously open up what you call the serial monitor within Arduino to see the raw values. So within Grasshopper, there we go. So there's just a couple of reasonably simple steps that you go through. So we check which ports are available, open up the panel and check out which port is available. So 42 is available. That's the port of the Arduino. When I when I open up this port into Grasshopper, so now rather than this from Arduino, this is just an interface to see all those numbers. Grasshopper can also act like this, but through Firefly. So if we try to open this now with port 42, while this is running, it won't let us. It'll go red because you can only access the data through one access point. So we have to close this, and then we open it, and it says message, hooray, serial port is open, awesome. And then what you can do is read in that serial data with the serial read, just a generic one. And we state which port it is, and start it, just another panel, and the output is that. So it's only gotten one value that's static at the moment, so we need to update this component, and we use the timer value to do that. So that will now update every second. We can change the interval of this one to say 200 milliseconds, and then using that value, we can just say greatest VF, for instance, out of that value. But at the moment my serial string has a bit of text there, so I need to just split that with I think it's just a space, it might be a tab, let's see. So this just splits it up into two lines, and then I can just use the list item, grab the second value, should just be the number here, and we'll chuck it into there, and zoom out a bit, and now we get some sort of representation of the wind speed just by the size of the sphere. And this is geometry that you can bake at any point, right? So you can just create a whole lot of different shapes, if you like, directly from that data. Yeah, so and then you can just visually see what happens when you change things. It's not changing much. So if it's not changing much, then what we can do is say remap the numbers, and set a target. So the source domain will be 0 to 1023, and the target, we'll clip these a little bit. So we're getting like low values of say 200, and we're going up to say 600. And I'll just use 0, 1, so now it's going to be really small, but it's going to change more. So let's see if we have an object like this. See how it's changing, fluctuating a lot? That's because it's in the wake region and it's like moving around a lot. Move it back a bit, it'll soften. Oh, no, still pretty turbulent. Let's make it a pretty color if you want. Just throw a preview on. And yeah, blue for wind. And so just hide all this other stuff. Yeah. So fluctuating lots. Go out here. It's not so bad. It's a little bit higher around here. You might see that there's this weird region just next to the block where it's really low, but then if you move in, it gets higher, lower, way higher. And so the wind is sort of accelerating. It's deflecting around the shape like this, like you've seen in the diagrams. And let's see what happens at the top as we just move up. Yeah, so there's a little bit of a variation from the top, and then we go towards the edge. It should accelerate a little bit, yeah, and then it'll get into a region where it goes a little bit chaotic, yeah, or almost zero. So you can start to sort of move around these objects and get a feel for the wind velocity at that particular point, but then link it back to the sort of diagrams that you've seen or images that you've seen, and gain an understanding about the effects that a certain shape have on on the speed of wind. Yeah. Are there any questions? After the break, we're going to come up with ways, like a framework to work within, so that we can begin to be really logical about how we learn certain phenomena of wind, and say how we're going to change this block, for instance. Are we going to make it twice as high or 3 times as high and see what the effect is, and that sort of thing, or is it that we're creating funnels, we're flattening out the funnel or changing the angle, just to 3 different angles, and then describing exactly what the effect is. So it's a very sort of engineered approach to understanding this phenomenon, and just gives you a bit of an insight into the way in which engineers have gone about understanding these phenomena and how complex it is as well. But distilling certain ideas about what the wind is doing in certain circumstances, and then yeah, and then you'll get the next assignment. Yeah, but in saying like, oh yeah, in giving you exposure to the way an engineer is kind of thinking about wind to a certain degree, that gives you the tools to be able to sort of, start to interface with the engineers a little bit with your design thinking. But within the course, we want you to demonstrate that you understand the perspective of the engineer, but the output should be really, really beautiful and demonstrate all of that, that chaos within the that is just fundamentally beautiful, and you should try and express that in a way in which you'll sort of have some element of control over it.